In this video, we're going to talk about absolute extrema and relative extrema. So extrema is kind of the plural for maximums and minimums. A maximum is a highest point, a minimum is a lowest point. And we have two different ones. So absolute is the number one highest. So think of that as like the one highest point in Ohio. There's only one. We call that absolute. Sometimes it's just called the maximum or the minimum. The formal definition is here. Basically, if you have a y value that's lower than every other y value, it's a minimum. If you have one y value that's higher than all the other y values, it is the maximum. A relative or a local extrema is a little bit different in the fact that it's any peak or valley. So think of it as like any hill or valley in Ohio is relative to what's around it. So again, that's any peak or valley, and we'll talk about that a little bit more in the next video. Extreme value theorem has been popping up on the AP test more recently. If f is continuous on a closed interval, so as long as you don't have to pick up your pencil at all, no open circles, even at the endpoints, then it must have a minimum and a maximum somewhere on the interval. So it has to have a highest point as long as it's continuous everywhere in that interval. A critical number is basically just like an important number. Something happens at that point. So we find them two ways. One, we set our derivative equal to 0. This is the most common. We also, though, need to see where we have values at which our derivative doesn't exist. That's going to be anywhere our denominator is equal to 0 of f prime. So if it doesn't exist, it's going to come to a sharp point. And you can see in this picture here, this is higher than everything around it. So that's a maximum, and that's why we have to check those places where our derivative doesn't exist. Anytime where our derivative is 0, that's going to create something here like a horizontal tangent line. This is a peak. This is a maximum. It could be also a minimum. Again, our derivative will equal 0 at that point. So here we just have an example. Here we have an interval, so it does not go on to infinity. So we have an absolute max, means the one highest point. And when it says at, it's asking for a location, which is a value of x. So the absolute one highest point is going to be right here, and it occurs at x equals 8. Now, the value is 12, but it occurs at x equals 8. The absolute min is the one lowest point, and that's going to be down here. Again, it occurs at x equals -1. The minimum value is -2, and it occurs at x equals -1. A relative max is any value that's relatively higher than everything around it. So in that case, think of it as like a peak. So here we have a relative max because this point is higher than everything right around it. And so again, it occurs at 2. And finally, a relative minimum is going to be any point that's relatively lower than everything around it. That occurs when x equals 5. If it asked me what the relative minimum is, then I'll say 3, but it occurs at x equals 5. So the way we find extrema on a closed interval, you can see that my highest point could be at an endpoint, like it was here, or it could be at a peak. So we have to check both of those. So to find the extrema, again, first we're going to find critical numbers, because if my highest point is somewhere in the middle, that will be at a critical number. So I have to find critical numbers. Also, you can see that my highest point, as in the example above, could be right here at this endpoint. So we have to check those as well. So we're going to find criticals and endpoints, and we're going to see which is the highest. So we're going to evaluate. We're basically going to find our y values. And the y value that's the highest is the max, and the y value that's the smallest is your absolute min. So here, find our critical numbers. Anytime we find critical numbers, we set the derivative equal to 0, and we also see where it does not exist. So in this case, this is not a fraction, meaning it exists everywhere, but I can find when it equals 0. And so here, if I factor out a 5x, I'm left with 3x plus 2. And any value that makes this true is a critical number. So here, I'll have a critical value of x equals 0. And if I set this guy equal to 0 and solve I'll get a critical number of negative 2/3. So I have 2 critical points on my graph. That means something interesting happens at those 2 points. Example 2, find the absolute maximum and the absolute minimum. So again, those values could be at the endpoints, but they also could be at the critical numbers. So we start by finding critical numbers. So here I'm going to have 24x squared minus 6x minus 9. When I set that equal to 0, I do need to factor and solve. So we are going to factor out a 3 first. And so when I factor, again, I need to set each of these equal to 0, and this guy never equals 0. So my critical number here is going to be 3/4, and my critical number here is going to be negative 1/2. And so my highest point could occur at either one of these, or it may occur at either one of those endpoints. So I have to now find the highest value. And so I'm going to use the position function, which is my original. So I'm going to plug in negative 1. I'm going to plug in 2. I'm going to plug in 3/4, and I'm going to plug in negative 1/2. And so I just plugged these in on a graphing calculator, and we can see here that the highest value occurs when x equals 2, and our lowest value occurs here. Now we just need to make sure we answer the question. This wants to know the actual values. So what are those values? And those values are going to be the y values. Their location is your x. So we would say we have an absolute minimum is negative 3.0625. That just means that's the lowest our graph is going to go ever on this interval. And my absolute maximum is going to be 36. Just means that's the highest that our graph is going to go, is up to 36. So here we have a trig function. We're going to do the same thing. So we need to find our critical values. We need to evaluate them. So in this case, my derivative is going to be 1 minus 2. The derivative of sine is just cosine. And I need to see when this guy equals 0 and when the derivative does not exist. In this case, cosine is over 1, so it exists everywhere. But I can set this equal to 0. If I take this guy to the other side, I get 1 equals 2 cosine x. If I divide by 2, I see that I'm looking for some angle in which the cosine is 1/2, or adjacent over hypotenuse equals 1/2. So I need that triangle, and we are looking from 0 to 2 pi, so we're going all the way around. So my first triangle, in which my adjacent side is 1 and my hypotenuse is 2, is going to be that 30, 60, 90. So this is a 60-degree angle, or pi over 3. Okay. The hypotenuse can never be negative, but my adjacent side would also be positive here in quadrant 4. So I'm also looking at this angle, which is x equals 5 pi over 3. And now again, I just need to see which of these is the highest and which of these is the lowest. So I have my endpoints, I have my criticals. I'm just plugging all of those into my position function. So I'm going to get rid of my unit circle here, and I'm going to find f of pi over 3. I'm going to find f of 5 pi over 3. I'm going to find f of 0 and f of 2 pi. So if we continue to evaluate, here we'll get pi over 3 minus 2 times the sine of pi over 3. So sine, again, is going to be opposite over hypotenuse, so it's going to be radical 3/2. Here, whoops, typo. So here we'll have 5 pi over 3. Down here, the sine of 5 pi over 3, again, is opposite over hypotenuse, so it's going to be negative radical 3. So we'll get 5 pi over 3 minus 2 times negative radical 3/2. I'm going to cut that.